Dear students, welcome back to the first PUC online classes. In this class, I am going to discuss about the different kinds of oscillations: free oscillations, damped oscillations, undamped oscillations, forced oscillations, and resonant oscillations and the resonance conditions. These are the different types of oscillations, and this is the last bit of your topic. Here, oscillation means it is a to and fro motion or back and forth motion about its mean position is called oscillatory motion. But free oscillation, the word itself says free oscillation means when a body is slightly displaces from its mean position. Now I consider this is the simple pendulum. Here L is the length of the thread and R is the radius of the bob. When this body is slightly displaces from its mean position and left to itself, it starts oscillating with a frequency of its own. These types of oscillations are called free oscillations. Already all of you have performed this experiment in your laboratory. Free oscillation, it means if the body is slightly displaces from its mean position and left to itself, it starts oscillating with the frequency of its own. ಒಂದು ಸಿಂಪಲ್ ಪೆಂಡುಲಮ್ ಇರಲಿ ಅಥವಾ ಬೇರೆ ಯಾವುದೇ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಇರಲಿ, ಹೌದಾ, ಇಲ್ಲಿ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ಆ್ಯಂಡ್ ವೈಬ್ರೇಷನ್ ಆಫ್ ಫ್ರಾಂಕ್ಸ್ ವಿತ್ ರಬ್ಬರ್ ಪ್ಯಾಡ್ ಅಂತ ಕರಿತೀವಿ. ಈ ರೀತಿ ಇರ್ತಕ್ಕಂಥ ಎಕ್ಸ್ಪೆರಿಮೆಂಟು ಕೂಡ ನಿಮ್ಮ ಫಸ್ಟ್ PUCಯಲ್ಲಿ ಇತ್ತು, ಬಟ್ ಈ ವರ್ಷ ಅದು ಡಿಲೀಟ್ ಆಗಿರೋದ್ರಿಂದ ನಿಮಗೆ ಅದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟನ್ನು ಮಾಡಿಸಿಲ್ಲ ನಾವು. ಬಟ್ ವೆನ್ ದ ಬಾಡಿ ಆಸಿಲೇಟ್ ಅಲಾಂಗ್ ಇಟ್ಸ್ ಓನ್ ಆಕ್ಸಿಸ್ ವಿತ್ their mean position without any disturbance, that type of oscillations are called free oscillations. And the frequency of the body it executing free oscillation, then it is called natural frequency. ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಆಬ್ಜೆಕ್ಟು ಮೀನ್ ಪೊಸಿಷನ್ ಅನ್ನು ಬಿಟ್ಟು ಹೊರಗೆ ಬಂದ್ರೆ and it starts oscillating with its own without any disturbance, then it is called natural frequency. The best example is the oscillation in simple pendulum and the vibration of Franck's and tuning fork. ಇಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅನ್ನ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ಅಂತ ಕರಿತೀವಿ ನಾವು. ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್, here it produces the different kinds of sound waves with the different frequencies. It depends on the forces applied on that body. When this fork is rubbed with this pad, or when here the sound waves are produced, here we use different kinds of tuning fork. Here the frequency is produced, the number of sound wave produced in 1 second, this is called the natural frequency. These types of oscillations are called free oscillations. Then the next kinds of oscillations, that is damped oscillation. It means the oscillation in which the amplitude is decreases gradually. Here amplitude means the maximum displacement of the wave from its mean position or maximum displacement of the particle from its mean position. This is called amplitude. Here this is the mean position and this is the extreme position. The maximum displacement of the particle from its mean position, this is called amplitude. The oscillation in which the amplitude is decreases gradually. With the passing the time. When you draw the graph between displacement versus time for this simple harmonic motion, displacement versus time, the oscillation in which the amplitude is decreases gradually with the passage of time. These are called damped oscillation. And the best example for this damped oscillations are the oscillations of a swing in air, oscillations of a swing in air, or the oscillations of a simple pendulum in air. When you perform the simple pendulum experiment in your laboratory, the amplitude of that simple pendulum is gradually decreases with respect to time. ಒಂದು ಸಾರಿ ನೀವು ಅದನ್ನು ಆಸಿಲೇಷನ್ ಮಾಡಿಬಿಟ್ಟಾಗ ಅದು ಆಸಿಲೇಟ್ ಆಗ್ತಿರುತ್ತೆ. ಹೌದು, ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಟೈಮ್ 30 ಸೆಕೆಂಡ್ 20 ಸೆಕೆಂಡ್ ಆರ್ 1 ಮಿನಿಟ್ ಮಾಡಿದಾಗ ಅದು ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಡಿಕ್ರೀಸ್ ಆಗುವಂತ ಹೋಗುತ್ತೆ. ಫೈನಲಿ ಇಟ್ ಕಮ್ಸ್ ಟು ರೆಸ್ಟ್ ಡ್ಯೂ ಟು ಅಪೋಸಿಷನ್ ಆಫ್ ಏರ್. Due to opposition of air. That type of oscillations are called damped oscillation. It means it is the oscillation in which the amplitude is decreases gradually with respect to time. ಒಂದು ಸಾರಿ ಸಿಂಪಲ್ ಪೆಂಡುಲಮ್ ಅನ್ನ ಏರ್ ಅಲ್ಲಿ ಆಸಿಲೇಟ್ ಮಾಡಿದಾಗ ಅದು ರೆಸ್ಟ್ ಆಗುತ್ತೆ. ಯಾಕೆ ರೆಸ್ಟ್ ಆಗುತ್ತೆ? ಡ್ಯೂ ಟು ಅಪೋಸಿಷನ್ ಆಫ್ ಏರ್. ಅಥವಾ ಸ್ಪ್ರಿಂಗ್ ಕಾನ್ಸ್ಟಂಟ್ ಅನ್ನ, when the mass is attached to the spring, when you pull that spring, the oscillations are produced, and that oscillations are always accelerated towards its mean position, right? Here the oscillations produced in the simple pendulum or spring constant, these are the best example for damped oscillations. In case of air only, due to opposition of air, the amplitude of the simple pendulum, the oscillations of simple pendulum or the oscillations due to the spring constant are decreases with respect to time due to opposition of air. These types of oscillations are called damped oscillation. And the next type is that is undamped oscillation. That is undamped oscillation. Here undamped oscillation means there is no decreases of the amplitude. The amplitude is remains constant with respect to time. The amplitude of the particle or the amplitude of the simple harmonic motion is remains constant. Here the amplitude of the particle, when you draw the graph between displacement versus time, the amplitude of the particle is remains constant with respect to time. These types of oscillations are called undamped oscillations. In the system, here the amplitude of the particle is decreases with respect to time, that is called damped oscillation. Here for an oscillating system, the energy is continuously supplied from outside the same rate, which energy is lost, then its amplitude can be maintained the constant. These types of oscillations are called undamped oscillations. For example, here pendulum clock, it is oscillating continuously along its own axis. When you supply the certain energy to that system, the pendulum clock is always oscillating along its own axis. That type of oscillations are called undamped oscillation. It requires a certain energy. And the another example is in case of oscillation driven by electrical or electronic circuit. Electrical or electronic circuit. Here, when you perform the electrical experiment or electronic experiment, ಇದುವರೆಗೆ ನೀವು ಮಾಡಿಲ್ಲ, ಮುಂದೆ ಬರ್ತದೆ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. when you perform the electronic experiment, CROs ಗಳಂತ ಕರೀತೀರಿ. ಈಗ ICUಗಳಲ್ಲಿ ಹಾಕಿದಾಗ ಒಂದು ಕಂಪ್ಯೂಟರ್ ರೀತಿ ಇರತಕ್ಕಂಥ ಮಾನಿಟರ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಆಸಿಲೇಷನ್ಸ್ ಗಳ ರೇಟ್ ಬರ್ತಿರುತ್ತೆ. Here that is called undamped oscillation. The amplitude of that system is do not decrease with respect to time. That type of oscillations are called undamped oscillation. It is very simple concept. And the next thing is forced oscillation. Forced oscillation. ಯಾವುದಕ್ಕೆ ನಾವು ಫೋರ್ಸ್ಡ್ ಆಸಿಲೇಷನ್ ಅಂತ ಕರಿತೀವಿ? when the body oscillates under the influence of external force, not with its own frequency. ಯಾವುದೇ ಒಂದು ಆಬ್ಜೆಕ್ಟು ತನ್ನಿಂದ ತಾನು ಆಸಿಲೇಟ್ ಆಗ್ತಿರೋದಿಲ್ಲ. ಅಂಥ ಆಬ್ಜೆಕ್ಟಿಗೆ ನೀವು ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸನ್ನು ಹಾಕಿದಾಗ ಅದು ಆಸಿಲೇಟ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತು ಅಂದ್ರೆ ಆ ರೀತಿ ಇರ್ತಕ್ಕಂಥ ಆಸಿಲೇಷನ್ಸ್ಗೆ ನಾವೇನಂತ ಕರಿತೀವಿ? ಫೋರ್ಸ್ಡ್ ಆಸಿಲೇಷನ್ ಅಂತ ಕರಿತೀವಿ. ಫೋರ್ಸ್ಡ್ ಆಸಿಲೇಷನ್ when the body oscillates under the influence of an external force and do not oscillate with its own frequency but the frequency of external force, then its oscillations are called forced oscillation. Here body, it cannot oscillate with its own frequency but it oscillate under the influence of external force, then it is called forced oscillation. Here the external agent which exerts the force, that is called driver. The oscillating system under the consideration, that is called driven body. Any object, here Any object, it do not oscillate with its own natural frequency or own frequency, but it oscillate under the influence of external force, then it is called forced oscillation. The word itself says ಯಾವುದೇ ಒಂದು ಆಬ್ಜೆಕ್ಟು ಆಸಿಲೇಟ್ ಆಗ್ತಿರೋದಿಲ್ಲ, ಬಟ್ ಅದಕ್ಕೆ ನಾವು ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್ ಅನ್ನು ಹಾಕಿ ಇನ್ಫ್ಲೂಯೆನ್ಸ್ ಅನ್ನು ಮಾಡಿ ಆಸಿಲೇಟ್ ಮಾಡಿದಾಗ ಅಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಕ್ಕಂಥ ಆಸಿಲೇಷನ್ ನಾವೇನಂತ ಕರಿತೀವಿ, ಫೋರ್ಸ್ಡ್ ಆಸಿಲೇಷನ್. ವೆನ್ ಅ ಬಾಡಿ oscillates under the influence of an external force and it does not produce its own frequency under the influence of external force, it is oscillates along its own axis. These types of oscillations are called forced oscillation. For example, here when the stem of a vibrating fork here, this is called vibrating fork. I think some of the CBSE and ICS student already have studied this tuning fork and vibrating fork concept, but NCERT student and state board student, I think you have not studied this concept. When the stem of the vibrating tuning fork, here this is the stem of the vibrating tuning fork, is pressed against a table, a loud sound is heard because the particles of the table are forced to vibrate with the frequency of the tuning fork. This is called forced oscillation. Or another example is bell. ನಿಮ್ಮ ಮನೆಯಲ್ಲಿ ಪೂಜೆಗಳನ್ನ ಮಾಡಬೇಕಾದ್ರೆ, ದೇವಸ್ಥಾನಗಳಲ್ಲಿ ಪೂಜೆಗಳನ್ನ ಮಾಡಬೇಕಾದ್ರೆ ಬೆಲ್ಗಳನ್ನ ಯೂಸ್ ಮಾಡ್ತೇನೆ, ಹೌದಾ? ಅದು ಬೆಲ್ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಆಸಿಲೇಟ್ ಆಗ್ತಿರುತ್ತೆ. ವೆನ್ ಯು ಅಪ್ಲೈಡಿಂಗ್ ದ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್ ಆನ್ ದಟ್ ಬೆಲ್, then only it will oscillates along its axis, otherwise it does not oscillate. That is the best example for forced oscillation here. And the soundboard of string instrument exerts forced oscillations, or in case of piano, here that produces the sound waves due to the oscillations, that is also called the forced oscillation. Forced oscillation means it cannot oscillate its own axis with its own axis, but it oscillates under the influence of external force, then it is called forced oscillation. And the next example is that is called resonant oscillation, or that is also called resonance. In a particular case of the forced oscillation, in which the frequency of the driving force is equal to the natural frequency of the driving force is equal to the natural frequency of the oscillator itself, then the amplitude is very large, that is called resonance. Where the natural frequency, suppose the one wave is moving in this direction with this amplitude, and another wave is moving in this direction, negative x direction, with this amplitude. When these two waves are collide with each other, here the maximum amplitude is produced. The crest of one wave is fall on the crest of another wave. The crest of one wave is fall on the crest of another waves. Here the maximum amplitude is formed. This is called the resonance, or where the natural frequency of the body and resonant frequency of the body, where the natural frequency and forced frequency of the body, they are equal with each other, or the applied frequency of the body and natural frequency of the body equal to each other. This condition is called resonance, where the applied frequency is equal to natural frequency. Natural frequency means the body is oscillate along its own axis without any force, without any disturbance. That is called natural frequency. When you apply the certain frequency or certain forces on that body, that is oscillate along its own axis with under the influence of external force. In that condition, the frequency is produced. Frequency means the number of oscillations taken in 1 second, or the reciprocal of time period is called frequency. Where the applied frequency is equal to the natural frequency, that is called resonance oscillation, or that is also called resonance. The phenomenon of increasing in amplitude when the driving force is close to the natural frequency of the oscillator, then it is called a resonance. At the resonance, applied frequency is equal to natural frequency. Here all the mechanical structure have one or more natural frequencies, and the structure is subjected to the external periodic driving force which matches one of these frequencies. Or in case of aircraft passing near the building shutters, its window panels if the natural frequency of the window matches with the frequency of sound waves sent by the aircraft engine, or earthquakes causes the devastation if the frequency of the oscillation produced by the earthquake coincide with the natural frequency of the small building. The building will oscillate with a large amplitude. Due to that resonance, it gets damaged. It is very simple concept. What is resonance? ಇಷ್ಟೇ ವ್ಯಾಲ್ಯೂವನ್ನು ತಿಳ್ಕೊಡ್ರಿ. ಇನ್ ಕೇಸ್ ಸೆಕೆಂಡ್ ಪಿ ಯು ಸಿಯಲ್ಲಿ ನೀವು ಅಲ್ಟರ್ನೇಟಿಂಗ್ ಕರೆಂಟ್ ಅಂತಕ್ಕಂಥ ಒಂದು ಟಾಪಿಕ್ ಅನ್ನು ಕಲಿತೀರಿ, ಅದರಲ್ಲಿ ಮಾತ್ರ ಇದು ಯೂಸ್ ಆಗ್ತಕ್ಕಂಥದ್ದು. ವೇರ್ ದ ನ್ಯಾಚುರಲ್ ಫ್ರೀಕ್ವೆನ್ಸಿ, ವೇರ್ ಎಕ್ಸ್ ಎಲ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಎಕ್ಸ್ ಸಿ ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು. ಎಕ್ಸ್ ಎಲ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಎಕ್ಸ್ ಸಿ, ವೇರ್ ದ ಅಪ್ಲೈಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಈಸ್ ಈಕ್ವಲ್ ಟು ನ್ಯಾಚುರಲ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ದಿಸ್ ಕಂಡೀಷನ್ ಈಸ್ ಕಾಲ್ಡ್ ರೆಸೊನೆನ್ಸ್. ರೆಸೊನೆನ್ಸ್ ಅಂತಕ್ಕಂಥ ಒಂದು ಸಪರೇಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ನೀವು ಸ್ಟಡಿ ಮಾಡ್ತೀರಿ ಅಲ್ಟರ್ನೇಟಿಂಗ್ ಕರೆಂಟ್ ಅಂತಕ್ಕಂಥ ಟಾಪಿಕ್ ಅಲ್ಲಿ. ಇದರ ಕಂಟಿನ್ಯೂಯೇಷನ್ ಟಾಪಿಕ್ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥದ್ದು ನಿಮಗೆ ರೆಸೊನೆನ್ಸ್, ವೇರ್ ದ applied frequency is equal to natural frequency, that is called resonance. And the marching soldiers break steps while crossing a bridge because it's quite likely that the frequency of footsteps may match with the natural frequency of the bridge. Due to that resonance, bridge may pick up a large amplitude and it may break. Right? This is very simple concept. ನೀವು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೇಕಾಗಿರ್ತಕ್ಕಂಥದ್ದಲ್ಲಿ ಅಟ್ ವಾಟ್ ಪಾಯಿಂಟ್ ಆರ್ ಅಟ್ ವಾಟ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಪ್ಲೈಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಈಸ್ ಈಕ್ವಲ್ ಟು ನ್ಯಾಚುರಲ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇತ್ತು ಅಂತಂದ್ರೆ ಈ ಕಂಡೀಷನ್ ಅನ್ನು ನಾವೇನಂತ ಕರಿತೀವಿ? ರೆಸೊನೆನ್ಸ್. ದೀಸ್ ಆರ್ ದ ಡಿಫರೆಂಟ್ ಕೈಂಡ್ಸ್ ಆಫ್ ಆಸಿಲೇಷನ್ಸ್. ಓಕೆ, ಫ್ರಮ್ ಯೂಸಿಂಗ್ ದಿಸ್ ಬ್ರೀಫ್ ಕಾನ್ಸೆಪ್ಟ್, ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ನೀವು ಹೈಯರ್ ಎಜುಕೇಶನ್ಗೆ ಹೋದಾಗ ಅಗೇನ್ ಇದನ್ನು ಸಿಂಪಲ್ ಹಾರ್ಮೋನಿಕ್ ಮೋಷನ್, ಫೋರ್ಸ್ಡ್ ಆಸಿಲೇಷನ್ಸ್, ಡ್ಯಾಂಪ್ಡ್ ಆಸಿಲೇಷನ್ಸ್, ಅನ್ಡ್ಯಾಂಪ್ಡ್ ಆಸಿಲೇಷನ್ಸ್ ಯಾವ ರೀತಿ ಆಗ್ತವು, ಇದರಲ್ಲಿ ಡಿಫ್ರೆಂಟ್ ಕೇಸ್ಗಳನ್ನ ನೀವು ಡಿಗ್ರಿ ಹೋದಾಗ ಸ್ಟಡಿ ಮಾಡ್ತೀರಿ. ಹೌದಾ? ಡಿಫ್ರೆಂಟ್ ಕೇಸ್. ದಿಸ್ ಇಸ್ ಓನ್ಲಿ ದ ಬೇಸಿಕ್ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಯುವರ್ ಸಿಲೆಬಸ್, ಬಟ್ ಓನ್ಲಿ ಯು ಹ್ಯಾವ್ ಟು ಕಾನ್ಸಂಟ್ರೇಟ್ ಆನ್ ದ simple harmonic motion or displacement of the simple harmonic motion and the characteristics of the simple harmonic motion, acceleration, velocity, and the energy of the simple harmonic motion, time period of the simple harmonic motion, with the different examples, spring constant and simple pendulum for your competitive examination. Okay, thank you. And in the next class I am going to start the last topic, that is kinetic theory of gases. That is very small topic. In the next 2 to 3 class I will discuss about that concept.